All right, hi grade 8s. Today we're going to be looking at 7.2, misrepresenting data. In the first section we looked at some of the advantages and disadvantages of different types of graphs, and in 7.2 we're going to look at how the way you display a graph can actually sometimes be misleading. So being able to recognize it and also being able to manipulate data. So here we're just going to start off right away here, graph A versus graph B. We're showing house prices in Victoria versus the Fraser Valley. So we can see house prices here. It's actually displaying the exact same information here, but both graphs are going to give a certain impression. The only difference is that in this graph we kind of have this squiggly line indicating we're skipping a bunch of values. And basically what that does is it changes the impression. This graph looks like Victoria's house prices are rising well above Fraser Valley. Whereas this one, it jumps up by 50, 100, 150, it jumps up steadily. So it is definitely rising in Victoria, but not by as large of an amount. Okay, so that's the impression that's given. Who might want to use each graph? Well, if I was somebody who was selling houses in Victoria, I would want to show probably this graph because I would say, well, it's actually not much more expensive. Whereas if I was someone selling houses in Fraser Valley, you might say to your customers, well, don't bother looking in Victoria, let's come to Fraser Valley, it's way cheaper. Right, so you can also start looking at why would you maybe, or what types of people might be trying to show me this type of graph. There's always a motive there. Okay, so we'll look at a few more examples here of just misrepresented data. So this one here, it's pretty obvious how it's being misrepresented because there's actually no precipitation levels given. It's just showing here's some bars. So if I just looked at this graph, I would see like Regina's here. Vancouver's like 9 times more precipitation than Regina, but we don't even know what that's representing. So of course, this one will actually tell us a little bit more. It'll give us the precipitation, but again, it still looks as if I didn't read the numbers, which people often don't, they just look at the graph, oh wow, that's striking, Vancouver way more than Regina. It is way more, but it's not 9 times as much, and if we actually put the number in, this is about 350 millimeters, and this is somewhere like 1100. It is quite a bit more, but it's not 9 times as much, right? So the way that we actually label our graphs can be somewhat misleading. On the next page, we see the actual properly labeled graph where we start at 0, so that everyone's fair, and then 200, 400, etc. Now if I look at Regina compared to Vancouver, it's maybe double or triple. It's definitely not 9 times as much, and Whitehorse actually registers on there. Right, so again, same thing, Whitehorse looked like it could be like 40 times, or Vancouver 40 times Whitehorse, but it's actually maybe 3 or 4 times. Okay, so the scale, the horizontal scale, can actually manipulate a graph to make it look more exaggerated than it actually is. Okay, that's just one way. There's lots of different ways to misrepresent graphs. Some of them are kind of really common sense, other ones are a little bit more creative. This example here, we're looking at who scored higher, boys or girls. Well, somebody's clearly cheering for the boys because it's way wider, right? The girls is actually higher, but it's kind of just drawing your attention to the bigger section of the graph. So when we're doing a bar graph, it's important to make the bars the same size. Don't mislead anyone in any way, whether it's accidentally or on purpose. Okay, pictographs, again, not used very often, but these are ones that are actually really hard to make equal because they're drawing like a picture of a ice cream cone, so you have to be really exact. But somebody clearly likes bubblegum because they want you to believe that bubblegum is the more popular one, when clearly chocolate is the favorite, right? And vanilla is drawn way smaller. Okay, so 2 pretty straightforward ways, I think, to misrepresent some data. Okay, it doesn't actually even have to be inaccurate. This example is showing our favorite music, and they actually, if you look closely, they're given the exact same information. It's just the scale. It's not even that they jumped values, but they actually just used a different scale. Each square represents 3 over here, so it's kind of zooming in on the graph a little bit, whereas each square only represents 10. So this one, when I look at it, it looks like pop, rock, and hip hop are fairly even. Like we still know that this is the most popular one and this is the least, but it doesn't look that extreme. But if I look at this one, it looks as if pop is almost double rock. So depending which one that you're interested in, maybe someone's trying to show that pop is the best. And so I'm going to use this graph to show it's way better than the other ones. Whereas someone might not care and they're just showing you that. Okay, so even though it's the exact same information, one can kind of zoom in and show it in a different way than another one. Okay, circle graphs sometimes can be misrepresented as well. Favorite drink. Water's clearly the biggest section, but by drawing this out and highlighting milk, somebody's obviously wanting you to think that milk is the most popular when it's not. Okay. So just jump into a couple examples. I'll mostly just reveal the answers. There's not much to write or to show. But here there's a conclusion that salaries have tripled in 6 years. And if I just look at the graph and I don't pay too much attention to the salary, 1, 2, 3, yeah, it looks like from here to here, it's like 3 times as high on the graph. But if you're not paying attention, the graph's actually starting at 33,000. It's not starting at 0, so it should be like way down on the grid. So it's actually going from just under 34,600 to 35,000. It actually pretty much has only risen 1,000. And so probably a better graph is shown in your book, and I just copied it here that you can kind of take a look. You're going to jump up by 10, 20, 30, 40. You can see, yeah, salaries are rising, but definitely not as extreme. And so again, we can think who might want us to see this and who might want us to see this. So probably the employer might show you this. See, look at, you come work for us. Look how much the salaries are increasing. Whereas someone who's not really involved might just show you this. Yes, they're going up, but it's not really super, not a whole lot, right? And so, and either way, as soon as you start looking at the numbers, you're going to see the truth anyways. Okay, it's just if you're kind of lazy and you just glance at the graph, you're going to notice, oh wow, that looks like it's going up. Okay, last example, number of plastic bottles being processed at a recycling company. Draw a graph. I'm actually just going to direct you to the different types of graphs. So you might be interested in showing, yeah, there's a huge increase, or maybe the increase isn't so much. And based on how you draw the graphs, it can really be misleading. So this one here, where you jump up to 2,600, you're kind of skipping a whole bunch of values, and you're only zooming in to these 500 values from 2,600 to 3,100. It's a difference of 500. If we draw it like this, it looks like a huge spike. Whereas if we look at the more gradual and just jumping by 1,000 every time and not skipping any values, and then it looks like, yeah, it's going up, but it's kind of a gradual, manageable change, right? So if you're wanting to hire more people and you're trying to show people how busy you are, you might want to show this one. Okay? If you're the employer, you might say, yeah, it's going up a little bit, but we're doing okay. Okay, so a few questions to practice over there, $3.99.